All right, down in front, please. Down in front. All right, we'll just go ahead and get started. I think that's probably all that's going to happen here. Can you guys hear me back there in the back? Awesome. All right. So my name is Rietschlin, and I am an Android developer at Chase. Today I'm going to be talking to you about the Google Identity Platform. So it is a suite of tools provided by Google that help you build a better authentication system. It makes it easier for developers to actually implement the auth system, and it makes it easier on the users to actually sign into your applications. Before I get started, I want to take a quick poll. Who are Android developers? All right. iOS developers? Anybody? Who's got this one guy? What about web developers? All right, cool. So especially the first half, Windows developers don't matter. So for the first half of the talk, pretty much everything applies to all platforms, right? And the code samples that I'm showing are going to be in Android, but again, the concepts still apply across all of the platforms. So before we get started as to what Google Identity Platform provides you, we'll go through kind of what it is trying to solve. And that is that authentication is hard. It's hard, particularly for users, right? So for users, one of the main things that's pretty hard is it's difficult to remember their passwords. So to alleviate that, a lot of users will tend to reuse the same password over and over again across different sites, and those passwords tend to be pretty insecure, right? So there's this company called Teams ID that compiled a list of 25 million passwords, and they ranked the top 25 most insecure passwords. And the worst offender on the list was 123456, followed by password. That's followed by 12345, which from a security standpoint is worse than number one on the list. That is followed by 123 through 8, which is more secure than number one, but only slightly. Followed oddly by football. So I'm not going to run through the whole list. There's quite a lot. There's 25. But doing a quick scan, you can see that one password, a variation of password, is on that list 3 times, coming in at number 18 with a 0 instead of O, and number 25 with password 1. And also, 9 of these passwords are a sequence of characters. So you can see QWERTY up there, any of the sequence of numbers, ABC, 1, 2, 3. Solo, I like that. That's pretty cool. It's Star Wars related. So, a whopping 10% of users will that took this survey use one of the passwords on this list of 25. So, passwords are a difficult thing, right? Not only that, but it's also difficult to remember which email address you may have used. I personally have several that I kind of cycle through for spam, more professional things. It can also be difficult to remember whether or not you have an account already on that site. You fill out the login form, only to find the little red box saying that the account already exists. And probably, one of the biggest things for users, one of the biggest deterrents for users is long sign-up forms, right? So what you want to do is try to shorten your login forms, because research shows that shortening your login forms can actually increase conversion by up to 160%. Research also shows that 86% of users are bothered by the mere presence of a login screen. So even just by having a login wall that blocking users from using your app will kind of make users not want to use your application. In fact, 54% of registrations are just abandoned. So instead, so users just want to get to the content, and they don't want to be deterred from doing that. And instead, they will tend to go to your competitors, right? So 26% of users will actually move on to another site that doesn't provide a login wall. So those are users that you could have that are instead going to your competitors. And also, about, I think 9 out of 10, about 90% of users will also give fake data just to speed through the login form. That way, they can just go about their business and get to what they want to get to. So the likelihood of actually receiving data could be wrong, right? And for kind of these studies, there's links in the corner that I will be providing. I'll put these slides online and put them in a Slack channel that is available. So authentication was hard for users. It can also be hard for developers. But since you're all developers, you probably already know that, so I'm just going to skip this. Not really, I'm just kidding. So for developers, one thing you have to do is you have to have some sort of application backend, right? You have to have an authentication system, a user database, and for that, it has to be reliable, right? If your site is never up, then no one's going to use your app. It has to be scalable. You want to eventually get to 1 billion users, and scalability is a whole industry of itself. Next, you're going to have to handle user credentials. And remember, passwords are often used over and over again, so you also want to make sure that everything is secure because you don't want to leak user information. Another thing to consider is it's not just passwords. These days, people are expecting to have their favorite social network as an option to sign in, and there are a number of different options to provide for signing in with some sort of social provider. This is probably just a short list of those. Excuse me. There we go. Also, like I said, users often forget their passwords, so you're going to have to implement some sort of password recovery flow. And you're also going to have to manage user sessions, right? So you want to make sure that the user doesn't have to log in every time they open up your application, so they're going to have to be long-lived. But you don't want to just create a session and have it live forever, so you're going to want to be able to have those passwords expire and refresh every once in a while. And also you want them to be revocable so that if something happens to the data, you can revoke the access, and that way the user will have to relog back into their application. And oftentimes you may also have to deal with a permission system, right? Different users are going to have different access to different data. For example, a moderator in a forum, for example, will be able to edit other people's posts, whereas regular users will not be able to do so. But it doesn't have to be that way. Authentication can be easy, and I'm going to show a few ways to make authentication easier for users, even without Google Identity Platform. So where possible, don't require a login at all. Just allow the user to use the app as a guest user. And because remember, 54% of users will abandon registration just because of a login. So you want to show as much as you can without requiring the user to sign in. If you want to present a login wall, first present an option for the user to skip and log in later. And you want to entice the user to sign up by offering incentives for signing in, giving them coupons, giving them discounts, something like that. An example, I used to work at Abercrombie & Fitch, and there we had guest sessions and allowed the users to browse the entire catalog, as well as save items, add them to your shopping bag, and even go through the entire purchase flow to purchase something and send it to your house. And that's all done without logging in. And the way that they entice users to sign in is they implemented a loyalty program that would give users kind of points over time to get discounts and the like. Another example is a good app that I like to use is called Series Guide. This allows you to track your favorite TV shows and your movies, and you can do that all without an account. But if you're going to get a new phone, you may lose that data, so you have to actually create an account for that to transfer across devices. Another thing is that this is not necessarily applicable to all applications. Some things like high security apps like banking applications, email apps, or password managers may require, you probably want to require the user to sign in for those. But you can do things to kind of ease the burden on the user, such as offering the option for a fingerprint so that the user can use their fingerprint to log in, which still eases the burden of them actually logging in. They don't have to insert a password. Oops, sorry about that. But one thing to note is that fingerprints are pretty 2016, so you may want to do face unlock now. So that is the new hot thing in town. Next, again, like I said earlier, we want to have a social sign-on option because that is one less password for the user to remember. It allows them to skip the password altogether, and oftentimes it's a lot faster, right? It's usually just a few clicks of a button rather than the user having to type in a password. And like I said, there's many options available, but at the very least, you probably want to use something like Facebook because it is the most widely used social sign-on mechanism, And if you're developing for Android, you probably want to have a Google sign-in method because 100% of your users are going to have a password or a Google account. So next, the next thing you can do is reduce your sign-up forms. Remember, reducing your sign-up forms can help reduce or increase conversion by 160%. And also, longer forms equal more friction. Another thing you can do is, instead of marking fields as required, mark the optional fields instead. Because what actually happens is required fields tend to have users do the bare minimum. They will kind of scan the page for the required fields, fill those out, and then move forward. When you do things, when you mark the optional fields, they will be more likely to fill it out in a linear fashion and therefore be more likely to fill out the optional fields. Another thing you can do is actually present the extra data that isn't necessarily required for a login in context inside of your application, right? So if you have a social application, present a profile screen rather than forcing them to give you your name at the login screen. And also just incentivize users to fill out data, right? Like at ANF, they will maybe give you extra loyalty points if you give them your birthday, for example. So that is kind of a rundown of some easy ways that you can just make sign-in easier for your users without having to really do much else, right? But now we'll get into what the Google Identity Platform has to offer to help ease the burden for you as developers and your users. And first, I'm going to talk about Smart Lock for passwords. This is a really cool feature that provides a really good user experience. And best of all, for you guys on Android, it is extremely easy to implement, especially Android. So first, a brief rundown as to what Smart Lock actually is. At a high level, it's essentially just a password manager built directly into your Google account. So you provide your credentials to Google, and it stores it securely, associating that data to your Google account. So how many of you have seen this dialog on Google Chrome where you're logging in and this pops up in the upper right-hand corner? Oftentimes you probably don't even think about it. You probably just click save and move on. And the next time you log into that site, the account fills the login form automatically for you. That's Smart Lock at work, actually. So it's integrated directly into Chrome and is cross-platform and can also offer a really cool auto sign-in feature, which is also cross-platform. So say you have a website. Oh, that's not good. Did I do something? Well, this is interesting. Cool. Sorry, guys. There it is. So, they have this awesome auto login feature where if you have a website and the user stores those credentials on the website, and then you introduce an Android app later on and they download the Android app, using Smart Lock, you can grab those credentials and sign the user in automatically without them having to insert any username or password. It's really cool, and I'll show you an example of that later. So I've got to find this here. And finally, they provide a mechanism to expose data for you, which is called a hint request. So a dialog will show, and you can get data to fill out the form on behalf of the user so that they don't have to do it manually. And they expose things like your email address, your first and last name, and also your password. So I'm going to jump into some examples, just quick videos, and I'm going to start with the hint request. So here you can see the user opens up the application, and a prompt displays. They click their account, and the fields are just automatically filled in for them. The data comes from the Smart Lock APIs, and all the user has to do is actually insert a password. Another benefit that this has is that there's no extra permissions required. So on Android, before 6.0, a way that the way that developers would often fill out the email address field for you would be that they would use this thing called get accounts. But starting in Android 6.0, that became what's called a dangerous permission, which would then show this big scary dialog that said the app wanted access to all of your accounts and data, which kind of deterred users from using that. So because this is baked into Google Play services, you don't have to have that extra dialog. Next, I'm going to show how to store passwords using kind of the password manager feature. In this instance, the user has already filled out the fields. They enter their password. They create the account. When the API result comes back, the same type of dialog that kind of shows in Chrome is displayed, and you can save the credentials to your Google account. It's really that simple. It's pretty easy to implement, which we'll see later. And finally, the auto login feature, right? So in this instance, the user has already saved the credentials, and we're starting from a fresh instance. In this example, I'm just deleting the data and reopening the app. So you can see that when it opens back up, so I'm clearing the data, then the app is opening, and then the little blue bar in the bottom there signifies that the user is automatically signed in without having to input any, they don't go to the login screen at all, they just go straight to the content of the application. So there's zero input by the user. So some of the, you can see how beneficial it is for adding smart lock for your users. Earlier we saw this slide about how it's difficult to remember passwords, emails, whether or not they have an account. All of this is kind of negated by smart lock, right? So with passwords, there's really no password input needed with the auto sign-in feature. When it comes to an email address, the email address is provided by Google. When it comes to whether or not they have an account, auto sign-in fixes that by automatically signing them in when possible. And the long sign-in forms are kind of it's reduced because of the hit request. So some of the data is automatically filled out for you. So that really just shows the benefits for users. But what about the benefit for developers, right? Smart lock is just another thing you have to implement. It doesn't actually help you as users, but those actually do translate to you as the developers because of the success that they're seeing, that companies are seeing who are using this. For example, Netflix is a company that they were a launch partner with this that launched about 2 years ago, the smart lock features. And with Netflix, it's an app that, because of digital streaming rights and all that, legalese stuff that they have to deal with, a login is required. And they implemented this and started seeing results immediately. About 30% of the users are actually signing in with smart lock. And a good 60% or so of the users who are prompted actually save the credentials into their Google account. And this is a big one because you can see that it can help save money across the company as a whole, because they saw a 20% reduction in customer support calls for users who were having trouble signing in with Android because of smart lock. And also, this was just implemented in a few days. From start to finish, and even with testing, according to the case studies. All the case studies that I'm linking to are down at the bottom of the slides there. And one of the coolest things, this is actually where I found out about smart lock for the first time. I opened up Netflix on my Android TV, and it just signed me in automatically. So I didn't have to use the clicker to navigate the keyboard on my TV, which is always a painful experience. A company called AliExpress also implemented this. They are an online retailer out of China. They're also seeing really good results, where 50% of the users are using the hint selector to fill out their forms. They are seeing that 95% of their users are actually storing their credentials into Google, and that this is a big one, probably because of the hint selector. They've seen a 60% decrease in the time users are spending signing up for their application. And also, this is implemented on the web for them as well, and they saw an 85% drop in failure rates for users signing up on the web. But it's not just these two companies. There's a host of other companies that have used smart lock, ranging from the New York Times to LinkedIn. All of these, some of these using like the auto sign-in features. So you can go to the link in the bottom there to find out more information about the companies that have used them and the benefits they're seeing. So we're going to get into some code samples. This would not be a developer conference without some code. And first, I'm going to show the hint request. So before I get started with that, I want to show they've actually updated the APIs recently. And some of you are Android developers. You've probably dealt with the Google API services before, or the Google Play services before, and seen that you have to, in the past, you've had to get a reference to this Google API client. Then you'd have to manually, state which APIs you want to use, connect to the APIs, and then sometime later down the line you would receive callbacks. Maybe it would connect, maybe it wouldn't, and when it finally did connect, you would be able to use it going forward, and then it could kind of crash any time and go into your on suspension there. But I think about a month or two ago, one of the latest releases, they've actually streamlined this a lot, and it's been kind of an ongoing process throughout all of their APIs on Google Play services. And now that same code is just these couple lines, right? So what you do is you get a reference to the credentials API or credentials client using the standard get client method that they provide throughout their APIs. That's the credentials client here. And then you call the get hint picker intent by passing in what's called a hint request. And that is just done here. You'll see a builder pattern used throughout the Google Play Services APIs. So you create a hint request builder object, passing it in a picker configuration, which I'll kind of explain a little bit later. They also support adding credentials for different identity providers, such as Facebook, Google, Twitter, and they recommend that you use the identity providers class there if you want to add support for those. And then you're going to tell what type of identifier you're actually supporting. In this case, we are supporting the email address identifier. And like I said earlier, you can also support phone numbers. So you would want to use the phone number identifier supported if you're going to go that route. So what you do then, after you get the pending intent, you're going to call this method start intent sender for result, which is on the activity. And if you're familiar with Android, you're probably familiar with a lot of these. Oh, sorry about that. This is actually what shows up when that call is made. And this is the dialog that is shown. And that picker configuration that I talked about earlier will tell Google Play Services what to show here. So in this instance, we're showing continue with. You can have sign in with or create account with, and also add a cancel button or adding an account. And it'll go through the add account process through the Google APIs there. And then if you're familiar with Android APIs, it'll come back into this onActivity result method. And assuming that it is successful, you'll get a credential object, and then you can just start using it and pulling out the information and filling out your forms. And that's all there is to it. It's as simple as that. For saving credentials, it's just as easy. You will use this builder pattern to create a credential object, passing in the identifier that you're supporting. So in this case, I'm passing in the email. If you supported phone numbers, you would pass in the phone number. Then you pass in the data associated with that credential, such as the password, if there's a name available, and maybe there's a profile picture. And like I said, you can also store social sign-on options. So maybe the user actually signed in with Twitter instead of a password. You could do that here. And then you just call the save object here, the save method. And if it succeeds, it'll go into the success block. But when storing credentials, that's probably not going to happen just automatically because you have to get permission to store those passwords. So it'll go into the failure block here, and you'll have to resolve that exception. And to do so, you check to see if it's this resolvable API exception, and then call the start resolution for result. Again, this is the standard kind of calling out to another application and receiving the results. And when that happens, you'll see this dialog, which is not unlike the dialog for Google Chrome, where the user can either save or not save the account. If the user saves, you'll get the callback in your onActivity result, and if it'll give you the result okay, the user saved the credentials to their account, and then you can just move forward. For requesting credentials, it's also just as simple. You create a credentials request object using the credential request builder, passing in the same information around the account types that you want to support. You also have to set this method if you support passwords. If you do not call this method, then the password will always come back null. And then from there, you just call request, and kind of the same thing will happen where it will go into the success block if it succeeds. So if you only have one account, it'll just go in there automatically. And if not, it'll go into the failure block where you can resolve in the same exact way as you would have with the saving the method. Yes?
The set account types, so that looks specific before Facebook and Google accounts?
So that they do have a suite of accounts that they support. And again, I left out the identity providers dot. There's a class called identity providers that has a whole list that they support. And you can input any string, technically, but they recommend that you use those. And that will show this dialog. So only if you have more than one account. If you have only one account, like I said, it'll just go into that success block. And if you have more than one, it'll show this dialog to the user. They select which account they want to use that they have already saved with. And when they do that, it'll come back into the on-activity result. Again, we're seeing the same pattern over and over again. And you can get the credential object and pass that into the same method you would have used if it had succeeded automatically. And that method looks like this, where you just get the object and can start using you get the email and the password and just pass it along to your server to automatically log them in. And that's it. So it's a really API to use, but there are a few caveats that you have to keep in mind. One is that with Android Oreo, they introduced a new API called the autofill API, which essentially promotes a password manager to the system level. So when you're saving, when the user signs in and then you call the save method, it may not show the dialog because it would instead go to the autofill API's version, right? And you can kind of get around that by calling this method on the auth credentials options object to enforce that they have to use the smart lock API. And that's it. Except it's Google, so there are a few bugs. This bug is logged, and you can find that in the bottom, but this builder class does not actually have a build method on it, so you can't actually build it. And even if you did, with the way that they've changed the APIs to the new credential client object, there's no way for you to pass this auth credentials options into the new credential client class. You would have to revert back to using the Google API client mechanism to do that. So again, it's logged, and hopefully they'll fix that in the next couple years. You'll also want to make sure that you disable auto login when the user logs out, because you can get into a tricky situation where it's kind of a login loop depending on how you implement it, right? So in this case, the user's logged in, they click log out, and it goes back to the same flows before and automatically log them in. So to get around that, you just call, this is what would happen if that didn't happen. There is a method, so they're logged in, they go to click log out, and in this case, they're taken directly through the same flow, but they go to the login screen instead of being logged in. So to do that, you call this disable auto sign-in method, and that tends to, what I've seen is it just goes directly into the success block. I haven't seen it actually go into the failure block yet, so and it's pretty quick, so you can do that pretty easily. But like I said earlier, this is just another thing that you have to implement as a developer. So it doesn't really alleviate any of these problems, right? Smart lock is more for the users, but luckily Google does provide something that essentially makes all of this not a problem, and that's with Firebase Authentication. Firebase is a platform provided by Google that essentially is a backend as a service, right? So you can implement databases, push notifications, and they also provide a really nice authentication system, which I'll run through a little bit here right now. So some of the features with Firebase Authentication is it is built on top of Google's services. So on top of their really highly tested, nice infrastructure, it is very secure. And because it's built on their Google Cloud platform, it's highly reliable. So their Google Cloud platform has a guarantee that there's at least 99.5% uptime. So you don't have to worry about any of the manageability of your servers. That's all done for you, and scalability as well. It's also multi-platform, so this can be used across the web, iOS, Android. They also have a C++ SDK as well as a Unity SDK for games. And it also adds multiple auth providers, right? So you can sign in with an email and password the standard way. They also provide several social sign-on options. I believe that's Google, Twitter, Facebook, and GitHub. And a relatively newer one is they also now allow you to use phone number authentication. I'm not sure when they added this, but it's new within the last year at least. And they do make a note that this is less secure, so that they would probably prefer you to use a password, but if you have to use this, it is available. And they also have a nice guest user, kind of guest authentication, anonymous user set of APIs that allows you to kind of give that perception of not having a login, but then you can easily link those accounts later. They also have really nice password recovery APIs, and also relatively new is that they have this integrate directly with the Firebase Dynamic Links, which is, if you're an iOS developer, you probably know it as App Links. I don't remember what it's called, but It's a newer thing that they just added so that you can provide a URL that it will send to the user in an email, and then using the dynamic links, if the app is installed, it will open up the app, and if it's not, it'll take the user to the Google Play Store or the App Store. It has automatic session management handling, so that you don't have to handle any of the revoking sessions, refreshing them, anything like that. That's all done by the SDK for you. And then it also has a really robust rule system. So harkening back to the permission system earlier, they have a very nice system to actually manage that. And this is a really complex topic, actually. So you could probably actually have a talk on just that system alone. And like I said, you can easily link accounts, right? So if you have your guest account and they are saving items or adding items to their bag, and then they want to sign in later, you can easily link those accounts together without having to manually transition the data, which I'll show that a little bit later on. And also, this is also relatively newer, that they allow you to integrate with your existing authentication system. So if you already have some sort of auth system in place and you want to start using some of the other beneficial things from Firebase, you can call this set of APIs, which will create a JSON web token that you can send to your server, and then from there on out, you can use the Firebase APIs instead of your own. So I'll jump into some code here. First, starting with getting the current user. So one of the first things you're going to want to do when you're dealing with the Firebase auth APIs is you're going to want to check if the user is logged in. And it's as simple as getting the current user on the Firebase auth API. So this Firebase auth is the kind of entry point to all things Firebase authentication in all of the SDKs. And to get the user, you just call the get current user object. If it's null, then they're not logged in. And if it is not null, then the user's logged in and you can proceed as a logged in user. And this down here just shows how you can add a listener to when that authentication state changes. So you'll get callbacks for when the user logs in or logs out. Excuse me. Next, we'll show some of the just authentication methods that they provide in the SDKs, starting with the password authentication. It's pretty easy, and you'll notice that a lot of the code that can be shared across platforms or across the different authentication methods. So first here, what you use when the user enters their username and password, you can call this method called create user with email and password, and it will log the user in. In the event that it's successful, you'll get a result and can then get the user and act on that user. If it fails, it'll go into the failure block just like before. And one thing to note is one of the main exceptions you'll see here is this auth user collision exception, which means that the user already exists or the password is not secure enough, something like that. All right, and if you want to, so that was the create account, and if you want to sign a user in, then all you really have to do is change the method that you call. So instead of create with an email and password, you're now calling sign in with email and password. And you can share the same code across all of that. And it's really that simple. With social, like I said, there's multiple social options that you can choose from: Google, Facebook, Twitter, GitHub. I'm going to show you how to sign in with Google. So first, you're going to want to add the Google Play Services authentication APIs. And to do this, all you have to do is provide a Google sign-in button on in your UI and build out this Google sign-in options object, passing in the web client that you get from your Google API client. And again, like I said, there's no more dealing with, the Google API console. There's no more dealing with the Google API client anymore. It's all done with this get client kind of template that they have throughout their APIs. And then you just call the start activity, and what that'll do is it will bring up this dialog, which if you notice, it looks almost identical to the same dialog that we had with the hit request. So it's essentially the same thing. When the user selects the account that they want to sign in with, it'll go back into this on activity result. You'll get it uses what's called the task API in the Google Play Services, and you can get that object, which will give you a Google sign-in account. And then so that's all from the start of this to now with the Google stuff that's all done in the Google Play Services authentications APIs. So now what you're going to do is you're going to take that object and pass it to the Firebase APIs with this Google auth provider.get credential, passing in the token that you receive from the account. And you'll get this auth credential object, which you can then use to log the user in. And that's done in this way by calling the sign in with credential method. And just like before, the methods are essentially identical as they were when you sign in with an email, so you can reuse the code there as well. So that was Google, and with the rest of them, it's almost identical, right? So you're going to use the SDKs associated with those social providers. In this case, get the Twitter session from the Twitter SDK, the Facebook access token from the Facebook SDK, and you're going to use the same mechanisms, but from the Firebase authentication APIs. In this case, the Twitter auth provider, get credential. It's the same thing across all the different providers. You'll return an auth credential, and you can reuse the same method that you logged in with for Google. So it's easy to, once you have one in place, it's relatively easy to actually implement others as well. Now for anonymous users, it's also incredibly simple. All you have to do is call the sign in anonymously method on the Firebase auth object, and it will return, again, in the same blocks that you had, blocks of code as you had earlier. You can reuse the same code. In this case, they also provide, the Firebase user does have is anonymous method on it, so that you can determine if the user is anonymous or not, so you can show or hide certain features. And then with linking an account, it's also really simple. So say that you sign the user in anonymously and they are saving things, and then they end up wanting to log in. So what you do then is you create this email auth provider, and you get an email auth credential, which is just identical to what we saw earlier. And you can call the link with credential method on the current user object. And again, you can reuse the same code from earlier. When it comes back in the success block, they are now linked. And kind of what that looks like. Also, you can do that with, like, say you're signed in with an email provider and they sign in with Facebook, you can link the Facebook account with that email. And the way that looks, kind of on the Firebase API console, is in this case, the user is signed in anonymously. They have a user ID, and you can just they offer little UI cues to say that this user is signed in anonymously in the provider column. And when you link the accounts, it really just changes the provider and adds the email. So the user ID stays the same, so you're able to easily associate the same data that you had with the anonymous user to the new logged in user. That's it. So, any questions? Yeah.
Should we just be using the Firebase auth now, or is there a reason that we would use Smart Log over Firebase auth?
So, you can use these both in sync, right? So the Smart Lock you can provide for the user to store. It's essentially a password manager for them, right, for the user. So what you would do is you could use these in sync by showing the Smart Lock on the sign-in screen that you create, and then when they provide their credentials, you would log in with Firebase, and then once that user is created, you would then store those credentials into Smart Lock. Yeah.
What's your opinion on the Firebase UI libraries?
I was going to bring that up, but I wasn't sure if I was going to have enough time. I haven't really looked into them too much. My personal opinion is that ties your UI too much to the backend provider, right? So if you were to switch away from Firebase, then it would be a lot harder for you to do that because you have to change all your UI code as well. Generally, I try to abstract this away into like presenters and stuff like that. That makes it a little easier. Anything else?
As more of these applications integrate with Smart Lock and some of those offers, is there still a need or use for third-party password managers like LastPass, or is this going to replace the need to use those services?
With Smart Lock, I would say it's probably more of a replacement for these third-party ones, but that's really up to the user if they want to use the Google. Some people might think providing more of their information to Google is a little scary, so they may choose to use an open source version or something like that. Cool.
How much with a simple web application, if I want to integrate this, do you recommend, or is it just very friendly or like comments? For mobile applications. So is that like that, or you can use it in web apps?
You can use it in web apps as well. So essentially all of the stuff that I showed in Java code, they have equivalents in like web SDKs as well. I think they support Node.js and a few other platforms as well. So it's really pretty simple to do as well. Yeah. Yeah.
Does it work if okay, like you can use it in an app, right?
Mhm.
In an app rather than a site, right? Does it work if that particular phone doesn't currently have that connection?
Yes, actually. So the question was, does it work if the user doesn't have a network connection? I don't necessarily know if the Firebase auth APIs themselves do, but Firebase does have as a whole, does have a nice offline mode. So like with their database, you can start to save things in a database, and then the SDK will manage the online and offline access and start transferring that over. I don't know why this keeps doing that. Sorry, guys.
Because out of curiosity, you happen to know what it's doing for that? Is it like doing sort of
I'm not entirely certain. I know that they have their own like database implementation. It's a NoSQL implementation, and it's like,
token?
I'm sorry, what's that?
Like maybe it's a token or something?
Yeah, I'm not really certain.
Okay.
Sorry. Yeah.
When implementing a social sign-on authentication mechanism, can you fetch back from the social network specific demographic information?
I think you can, but you would want to end up using their individual SDKs for that. This just essentially gives a way for you to associate the user in your database with that social network, right? So then you can then start pulling from the social network's SDK and inserting that data into your Firebase database.
Does
Yeah,
the data
sorry.
get differentiated at all if you're trying to get data from a Google sign-on versus Facebook versus GitHub? Like, as you access data, his username, his email, is it the same, or does Google's authentication provide more info?
I believe it's the same. I think they do differentiate, at least like on the UI console. Like it does know whether or not it's Facebook or it's Twitter. But when it comes, and that's just the user portal of it. If you want to do that, like if you want to associate different things with your user data, you would have to do that manually, I think.
Okay.
Anything else?
Authentication is that on GitHub?
Not yet. So there is. So you saw the Ohio DevFest app. I am working on. Hopefully, going to try and open source that, put that on GitHub soon, which will be there. I can post in the Slack channel if and when I do that. Hopefully, I can do that in the next couple weeks. Cool. Well, thank you.